Greetings! In this video, we'll close out chapter 20, finish up with some duration measures and discussion, find the duration of a bond portfolio. No mini exercise in this video, but let's get into it. Remember the three duration measures we were talking about: Macaulay duration, weighted average time to maturity. Let's check it out in the spreadsheet we've been working with. Duration and immunization from April 2nd under in-class exercises. Here's the work we left off with. All right. This bond at the top, Macaulay duration, 3.589 years. That's a weighted average time to maturity. Modified duration, percent change in price approximately for a 1% change in discount rate, yield to maturity, right? So for this bond, if interest rates fall by 1 percentage point, the bond's price will rise by about 3.369%. And then dollar duration is the change in price in dollar terms for a 1% change in interest rates. So if interest rates rise by 100 basis points by 1%, this bond's price will fall by about $35.43. I guess we could check that. Let's put in a yield to maturity of 7.5%, corresponding to an increase in interest rates of about 100 basis points. This bond's price should fall by about $35.43. And it does. Not exactly, because duration is an approximation, but pretty close. So, a couple properties of duration that I want us to be aware of, really just the first one. A zero coupon bond, in other words, just one cash flow. The Macaulay duration is equal to the maturity of that cash flow. Let's take a look at that on the immunization tab here. We've got a liability stream that we'll work with in a future video, but for now you see it looks like a zero coupon bond. There's no interest payments, so there's just one payment at the time the bond matures. So 100% of this liability stream's cash flows happen at the time of maturity. So the Macaulay duration of this liability stream is just 4 years. Okay. You can take a look and read up on some of these other properties of duration at your leisure. Okay. Another property of duration is that a portfolio of bonds, its duration is just equal to the weighted average of the individual bond durations, right? Whether it's Macaulay duration, modified duration, dollar duration, okay? And let's illustrate that in the immunization tab of the spreadsheet. So here's 3 bonds. You see in the immunization sheet down at the bottom half, we've got 3 bonds that mature in 2, 5, and 10 years respectively. See that? And then here's different coupon rates, different discount rates. We found the price already. And then we can find the duration using the Macaulay duration using the equals duration function. Just put in all these arguments like we did in a previous video. Coupon, yield, annual payments. The basis doesn't matter because the settlement date is the date purchased. And then we copy and paste this over. Here's the Macaulay durations. Now the modified duration equals M duration, a function of the settlement, maturity, coupon, yield to maturity, and the frequency, annual. Okay, and so we see that bonds with longer maturities have more interest rate risk, which I think we've talked about already. This 10-year bond, a 1%, 100 basis point change in interest rates is associated with a 6.3% decline in the bond's price. Compare that to the short-term bond. If interest rates rise by 100 basis points, this bond's price declines by less than 2%, right? So we can see higher duration means more interest rate risk. So now on to a portfolio's duration. We've got a little architecture here that lets us build a portfolio of these 3 bonds, right? They're all trading at a premium. So if we buy $1,000 worth of par value, $1,000 of face amount, and the price of the bond is $1,019, right? We're going to pay the market value of that position is going to be exactly equal to the price of the bond. Suppose I buy $5,000 of this first bond, right? In par value terminology. And then if we look at bond B, suppose we buy $3,000 worth of par value or face amount of bond B. There's the market value of that position. And then let's say we got 4,500 of bond C. So then we have a total of $12,500 worth of face amount or par amount. The market value of a portfolio like this is $13,000 about. And so the modified duration of this portfolio is just a function of the percent of our portfolio invested in each of the three bonds. And you can see these weights update automatically, right? So 38.8% of our portfolio is invested in bond A, and 24.8 in bond B, and 36.5 in bond C. You get it, right? So the portfolio's modified duration is just a weighted average of the bond's modified durations, where the weights is the percentage of our money invested in each bond. So let's use sum product equivalent to just taking each weight times each modified duration and adding them up, right? We could also use an array formula, but if we take equal sum product of each weight as the first range of the first argument to the function, and then the second argument is these modified durations, this will give us the weighted average modified duration, which is exactly what this formula is saying. Take each weight times each duration and add them up. That's what sum product does. So the portfolio has a modified duration of 4.048. So with this bond portfolio, 100 basis point change in interest rates is associated with a 404.8 basis point change in the portfolio's value. Right? Interest rates rise by 1 percentage point. The portfolio's market value will decline by about 4.048 percentage points. And then the dollar duration, we can just take the modified duration, right? And actually, let's take the modified duration divided by 100 times the portfolio's market value following the portfolio modified, the dollar duration formula, where instead of the price of one bond, we've got the market value of the portfolio here. Portfolio modified duration divided by 100 times the price. That's what this formula looks like right here. So in dollar terms, a 100 basis point increase in interest rates is associated with a decline in the market value of this bond portfolio of $531.81. All right? So from here, we'll be able to find the duration of a bond portfolio. That's going to be really useful in the next video when we start figuring out how do we insulate a bond portfolio from changes in interest rates, right? How do we immunize a portfolio from interest rate risk? That's the next video. Thanks for tuning into this one. See you next time.